Hi there, let's do this Euclidean Geometry exam question. So here we are going to prove the circle geometry theorem that states that the opposite angles of a cyclic quadrilateral are supplementary. Okay, so here we've been given A, B, C, D, which is our cyclic quadrilateral, and they want us to prove that B over there and angle D over there add up to 180 degrees. So to start with our proof, we're going to do a construction. So construction, and then we are going to draw, the first line would be from O to A, and then the second one would be from O to C. This allows us to be able to then use the angles that are at the center to prove that these angles B and D are supplementary. So we're going to label this angle closer to D1 and the angle closer to B as 2. So now we've got O1 and O2. And looking at the shape, we'll now be able to use the theorem that states that angle at the center is twice the angle at the circumference. Okay, so we're going to start with O1. O1 is on this side over here. So that means the angle that is at the circumference would be B over there. Thus, O1 is twice the angle at B, and our reason is that angle at center is 2 times angle at circumference. Okay, now we have O1. Next is O2. So O2, let me change colors. O2 is this angle on the other side there. So the angle that is opposite that would be angle D right over here. Therefore, O2 is twice the size of angle at D, and it's also because angle at center is twice the angle at circumference. All right, so now we have done that. The next step is to add angle O1 and O2. So O1 plus angle O2 equals to 360 degrees because it is a revolution. Now here is where it gets fun. So you see with O1, we already know that it's equal to 2B. So we can replace that with 2B. And at O2, we can replace that with 2D. And it's still equal to 360 degrees. All right, so now that we have that, we can now simplify and just divide both sides by 2 so that we have what B and D add up to. So divide by 2, meaning that here you now have B by itself, and here you've got D by itself, and 360 divided by 2 is 180 degrees. And there you go. We have proved that opposite angles inside of a cyclic quadrilateral are supplementary.